Landing gear malfunction. Emergency situation, mayday, and emergency landing preparation. Belly and tri-arc landing and runway slide.
We have a significant scrape along the keel beam. Assessment underway.
The beginning of a seemingly normal flight. On the morning of November 5, 1997, Virgin Atlantic Flight 024 left Los Angeles to perform a transcontinental journey to London. This was a routine flight with nothing special to draw the attention of veterans like myself. On the LAX runway, the Airbus A340-311 registered as GVSKY sat ready, its long body sleek like a metal arrow built to cross the ocean. The 4 engines operated stably, showing no signs that it was about to become the center of a rare incident in the industry's history. The aircraft carried 114 people, 98 passengers and 16 crew members, not a large number for a long-range airframe. The flight crew was accustomed to the steady rhythm of transatlantic night flights, and the A340 was always viewed as a stable machine, much more obedient than the older generation jets as it taxied to the runway. Everything was within desired limits. No strange warnings, no abnormal vibrations. With my experience of over 3 decades, I know that the most serious incidents often begin with moments that are too quiet, so quiet that one could easily believe they have mastered every variable. On the control radar, GVSKY gradually disappeared toward the Pacific Ocean, climbing to cruising altitude and stabilizing its speed. No one at that time, not even the engineers monitoring the data, realized that right inside the left landing gear bay, a tiny part had shifted out of its standard position, waiting for the chance to cause an incident. A flight considered normal, with favorable weather and a clear plan, was carrying a silent problem that no automated system predicted. That is exactly what makes us in the industry always maintain vigilance. A flight can start completely calmly, but if just a single mechanical detail fails to operate correctly in the first minute after takeoff, the entire story that follows will change direction. And Flight 024, though it started like thousands of flights before it, was gradually heading toward a moment where normality would be torn apart by just a small metal bar that was misaligned in the gear bay. The first warning and the shadow of a mechanical failure. As Flight 024 began its descent toward London Heathrow, the screen in the cockpit suddenly displayed a message that no veteran ever wants to see: unsafe gear. It is not a rare error, but it is never a minor error. The aircraft signaled that the left main landing gear, the part that would bear most of the weight upon touchdown, refused to lock into the fixed position. In the system, this is like the door of a bunker refusing to latch, even though everything looks normal from the outside. The A340 has a fairly durable landing gear structure, but when the locking mechanism doesn't hit the right point, it remains in a state of limbo, open but not enough to bear the load, and not closed to avoid damage. The crew retried the gear extension procedure using the main system, then switched to the manual method, what the industry calls a gravity drop, which is simply letting gravity pull the gear set down to lock into position. However, the left gear still refused to catch the point. This indicated that something inside was jammed. A joint, a support bar, or a pivot shaft deviated by just a few millimeters, but enough to ruin the entire operation chain. This is the type of error that is not noisy but extremely troublesome. The system doesn't report a complete failure, but it also doesn't confirm it is safe. It placed the crew in a position where they had to weigh every step, because a gear that isn't truly locked means the aircraft has only 2 options. Either land in a situation lacking support, or continue circling to find a solution while fuel gradually decreases. At low altitude, the closer to the airport, the fewer chances there are to maneuver. And right at that moment, Flight 024 stepped from a normal flight into a real technical test, where just one small misaligned part was enough to rewrite the entire end of the journey. Circling in the sky and the final visual check decision. When Flight 024 approached the runway, just 2.5 nautical miles out, the crew was forced to choose the only option safe enough: go around. This was not a stunt but a necessary step back, like pulling a car out of the lane to check the wheels before going down a long slope. The aircraft powered up, escaped the landing trajectory, and climbed to a safe altitude to give the cockpit team a few more minutes to observe every indicator again. In the industry, when a system reports a half-hearted error like that, no one wants to rely entirely on the screens. The crew needed real eyes to confirm what the sensors were only suspecting, so they chose a solution that Heathrow rarely has to perform: flying the aircraft low past the control tower. This is a maneuver requiring tight coordination from both sides. The cockpit maintains a stable flight path, while the controllers on the ground used binoculars to look directly at the left landing gear as the A340 glided slowly past the tower. The observation results were transmitted immediately. The left gear was not in the correct position, was not fully locked, and could not be considered ready to bear the load. For a veteran, that was a definitive answer. There was no room left for vague hope in a faulty sensor or a false alarm. Flight 024 was truly facing a gear that was only partially open, meaning upon touchdown, the aircraft would not have enough 3 support points as designed. From that moment, all plans had to be readjusted. The crew understood they were about to enter an unbalanced landing, something training courses always describe clearly. Risk of veering off course, risk of one side of the fuselage scraping the runway, and the load shifting to the 2 remaining gear sets. The go-around was not just to stall for time. It was the opening move to correctly assess the situation, before bringing an aircraft weighing tens of tons into a touchdown that no one wants but must still prepare for with precision. Declaring emergency and the one-sided landing strategy. When the observation results from the control tower confirmed the left gear could not lock into position, the flight crew understood they had reached the final boundary of all technical options. They retried the normal system, then switched to the gravity drop mechanism, colloquially called letting the weight pull the gear down. But despite following the correct procedure, the left gear remained stubbornly in a halfway state. For a veteran, that was a sign that the mechanical problem had gone beyond the scope of handling in the air. With no other choice, the captain declared Mayday, a step signaling that the aircraft now required absolute priority. This was not spoken for drama, but to clearly define the status of Flight 024, so the entire ground system would be ready. No one wants to use that word, but in that moment, it was critical to create an accurate picture for everyone supporting from the ground. After the emergency declaration, the landing approach was adjusted to runway 27L. This was a calculated choice, not random. This runway ensured that if the aircraft leaned to the left upon touchdown, it would lean toward an open space, reducing the risk of sliding into areas with structures or vehicles. In situations like this, the important thing is not just being able to land, but landing in a way that minimizes the spread of risk. The crew had to prepare in advance for a touchdown lacking 1 support point, something no aircraft is designed to do regularly. They calculated the landing angle, speed, how to use reverse thrust, and even the possibility that the left gear might collapse completely when the aircraft banked. Every step had to be viewed as the final step before bringing the fuselage, weighing tens of tons, down to the ground with only 2 remaining gear sets. Flight 024 was no longer a routine flight. It had become a real-world test of every safety rule in the industry. The leaning journey on the Gatwick runway. The Virgin Atlantic Boeing 747 was approaching the ground in a state no one desires. Only the 2 main right gears and the nose gear were tasked with making contact, while the left gear remained still in the bay as if locked tight. After over an hour of circling to burn fuel and prepare for the worst-case scenario, the crew was forced to make the only remaining choice: land with half a set of legs not working. When the right wheels touched the runway and the fuselage began to bear the real weight, everything happened very fast. The touchdown was not hard but clear, like a knock on a table signaling it's time. With only one side having support, the left fuselage dropped lower than normal. Just seconds later, the outermost left engine began to lightly scrape the road surface, causing strings of sparks to bounce behind like metal striking concrete. The right wheels bore an abnormal load, and one of them couldn't hold up and exploded, leaving a short trail of smoke behind. The aircraft, weighing hundreds of tons, continued to slide along the runway, tilting a little more to the left with every moment. It was not a chaotic tilt, but a long, slow slide full of pressure, like a massive door trying to keep its balance in a strong wind. The long runway gave the crew enough space to control the 747, keeping it within the white lines until the speed dropped to a safe level. Finally, the aircraft stopped completely after a few thousand feet, standing slightly skewed to the left but incredibly intact. And that very moment concluded one of the most cold-blooded and precise leaning landings in civil aviation history. A moment of survival after a unique landing. When the 747 stopped on the runway, the left fuselage still bearing the scrape marks on the ground, the situation was not yet fully over. At this point, the mission shifted to the final step: getting everyone out before any secondary risks could appear. With what the aircraft had just undergone, this was the time for every small detail in the evacuation procedure to operate as smoothly as a clock. The emergency exits were opened, the slide rafts deployed at the correct speed, and groups of people were guided out of the cabin one by one. Everything happened fast but without chaos. In this industry, people still say that once the metal touches the ground, the humans are the most important part. And the scene at Gatwick that day proved that clearly. All 114 people left the aircraft safely, a number that anyone in the profession must admit was much luckier than what the initial scenario could have led to. Only 7 people suffered minor scrapes while sliding down the rafts. Injuries of the hitting a wooden door too hard type, nothing serious. Those numbers speak to the fact that although the aircraft had to land with a configuration almost off balance, the crew still preserved the most important part, the safety of everyone's lives. When the rescue vehicles approached for a final assessment, no one showed signs of being heavily affected. This was not just the result of a precise landing, but also proof of the 747's design. A steel frame built to endure tough situations, along with the standardization in every step of the evacuation process. Looking back at the whole event, luck was not the main factor. It was a combination of technique, experience, and a series of decisive calls, helping to turn a situation that could have gone in a completely different direction into a complete story of survival. This is exactly why such incidents continue to be analyzed thoroughly, to understand that behind every safe flight is an entire system built to withstand the most unexpected moments. The final piece of a unique incident. After everyone had left the 747 and the runway was cleared, the biggest remaining question revolved around a seemingly tiny mechanical detail. Why did a landing gear refuse to lower as designed? The answer lay in a brake force transfer rod, what those in the industry call a torque rod. On wheel number 6, this rod had detached right after the aircraft left the ground. When it flew out of its original position, it became jammed in the gear bay like a misplaced pin, completely blocking the path of the left gear. And just a small deviation like that was enough to make the entire system stop working. The equipment beneath the fuselage bearing the landing force was deformed, the left engine had a long scrape, and the underside of the wing suffered heavy impact. But the aircraft could still be repaired, have important clusters replaced, and return to the sky not long after. In this industry, it is not the first time a large steel frame like that has overcome a difficult challenge. What is more important is what happened afterward. The incident forced maintenance teams and manufacturers to review the entire inspection process for the torque rod on similar aircraft types. Small parts, often easily overlooked, were put on a list for stricter inspection. Maintenance procedures were updated, and flight crews were trained more deeply for gear not locked situations, something that previously only lay in the rare category of the manual. Lessons like this are not retold to create drama. They exist to remind us that in aviation, sometimes a metal bar only as long as an arm can put an entire flight in a difficult position. And every time a crew brings an aircraft back intact, like the story that day at Gatwick, the industry gains another reason to strengthen the system so that no one has to encounter it again.